Hey everyone. So my name is Abe Brown, um, and I'm excited to present my final project today, which is about predicting NCAA tournament seeding using BartTorvik's data. And obviously, this is my Sports Analytics 602 final project. And yeah, so first, we're going to go into my research topic. So bracketology, obviously, we know Joe Lenardi, we know all the big names in the bracketology world, and this is an ever-evolving world of both predictions, analysis, but also media coverage, as bracketology has increasingly become a spectacle that people are really interested in following along with throughout the season. And obviously, here at Syracuse has always been seems like a bubble team going in the 11th seed, looking for their name on Selection Sunday. So teams are always looking at who will be in, who will be out, and fans as well. And where the teams will be seated as well, in addition to just if they'll make it, also captures the sports world every Selection Sunday as fans they say, oh, this team made a 6 seed when they should have been really only a 9 seed. And clearly, as we've gone along, we know that advanced metrics are considered by the committee. We know this because they publish their metrics and their criteria that they use to select teams, but so are many other qualitative and quantitative factors. So this really brings up the question of how much of the committee's decision-making process is actually due to these advanced metrics, and how can we predict using them? So that brings it to my research questions. First is, what advanced metrics actually best predict tournament seeding? Is it offensive efficiency? Is it defensive efficiency? Is it tempo? Is it strength of schedule? And then the next question is, how accurately using our linear regression model can we predict seeds using these metrics? Finally, what teams are seeded better or worse than their metrics suggest? And is there a pattern to these outliers? So next, I want to get into my methodology that I use when doing this project. And the scraping of the data did prove to be slightly difficult. In the end, we decided to use BartTorvik's data. And this was used because the site is completely free, and there were many useful columns to use for analysis. So there were things that were not included in other sites that were easier to scrape through BartTorvik. And additionally, I did want to use the Ken Palm data. Obviously, Ken Pomeroy, this is kind of the gold standard for these efficiency and analytics sites within college basketball. But the data proved hard to scrape, and there was also no direct information about which seeds teams had through Ken Palm. And the merging of other data sets due to difference between team names along different sites was pretty difficult. So in the end, I found a package in R, which is the Torvik package, as you can see here. And this was used to scrape the data as this contained a ton, almost all of the Bart Torvik data, since the web scraping did prove to be a bit challenging. So we analyzed data from 2013 to 2023, obviously not fully modern. We didn't have the 2024 or the 2025 NCAA tournaments included. And the reason for this was that this is the final year that there was updated package data in the Torvik package downloaded from CRAN that we could use. So who is Bart Torvik? So Bart Torvik is a Madison, Wisconsin native, and he launched into prominence during this whole analytical revolution in college basketball, especially as, Selection Sunday and the prediction markets have continued to grow in prominence. Bart Torvik created the T rank, Torvik rank, which is an efficiency-based metric which combines offensive and defensive efficiency of teams, similar to how it would on Evan Maya or Ken Palm, if you're familiar with either of those. So basically, it's how efficient a team is on offense. Oops, sorry. How efficient a team is on offense and defense. They look at tempo. They look at other rates that affect the teams, and it's also all filtered through strength of schedule and how good the opponents are. So your efficiency will not grow so much when you beat a mid-major or low conference team by 5 points. But if you blow them out, this will help. And additionally, if your team beats great teams, that's really how you'll, rise up in the ranks in these rankings. And specifically compared to KenPom, the T rank puts more emphasis on recent results, and it also attempts to filter out garbage time, which I think is super important, especially during college basketball. We know most teams are playing short rotations. Syracuse for years was known to play five, like realistically six players in rotation. So when the game is 80 to 53 and you bring in some walk-ons or lower level players off the bench, it really shouldn't affect too much of the data. So I think this is a good idea. And it also puts a lot of more emphasis on recent results, which we'll talk to later when we talk about one of the outliers. But I think this is good too because momentum is important, and especially in college sports, we know if a team is on a run, the run is real. So BartTorvik has become one of the most respected names in this analytics world, and we're gonna just take a quick look at his site here. So you can see here, this is the ranking so far in 2026. Sorry. And you can see we have 2026. You can see we have Michigan on top as they've been off to a great 9-0 start. And you can see over here all the information we get, right? So adjusted offense, adjusted defense, the BART algorithm, which is the kind of crowning part that ties all these rankings together. This is what they uh, by default sort the data by. And this is supposed to be the chance of beating average D1 team. So you can see Michigan at this moment, 98 over a 98% chance of beating the average Division One team, which is pretty crazy. And you can see there's other good information here. You know, we have information about who that team is facing off against today. And yeah, so a ton of great data here. You can see the green and the red. Green for obviously team is up at the top of this rank, and then red if they're down below. So if we were to scroll to the bottom, we could see, you know, a lot more red coming down here. And all the way down to the bottom, where you can see my alma mater, Binghamton, struggling so far this season. So that's a little bit about the BartTorvik data. Now we will get back to the presentation. So moving on, now that we looked a little bit about the BartTorvik data itself, we're going to look at the kind of a few plots that I've created to generalize this data and show what this data looks like. So we can see here the rating distribution by seed. And you can see, you know, clear groups come up here. So obviously 1 seeds and 2 seeds pretty high up above the rest, which a lot of people have been looking at when they make their brackets pretty recently, that 1s and 2 seeds are really a step above the rest of the competition. Because you can see the 3 through 5 category does bunch up pretty well as the 6 through 11 over here. It's pretty bunched up. You do see a significant drop off once you get to the 12 seeds. And a lot of that I think is because these teams are usually the, you know, mid majors, teams like that. The 12 seeds and the 13 seeds still do perform pretty well. Once you get down in the 14, 15, 16, these teams aren't obviously as strong. And you can see that they do have pretty low BART algorithm ratings, low chances of beating the average D1 team. So when we look at this, if you're looking to make your bracket predictions, I've definitely 1 seeds and 2 seeds step above the rest. So the next thing is the efficiencies by seed. So you can see the offensive and defensive efficiency. So for defensive efficiency, a lower metric is better. So you want to be down here in this bottom right corner with a higher offense and a lower defense. And if you see on the right the colors, you can see that it does really translate in terms of how the efficiencies are and the seeds that those teams have. So I would say that this definitely proves the need for, you know, the analysis in this area, as it looks like teams with the higher offensive efficiencies and lower defensive efficiencies, they do get the higher seeds. So this really shows that the committee, whether directly or indirectly, they are taking factors like this into account, and they are looking at um, these analytical models to help them in their seeding. The last plot over here shows team performance by seed. And the reason that I think this plot is important to look at is it shows that the seeding does matter. So this data was also taken in the BartTorvik package. There's information about each March Madness and what rounds teams get to. So to create this, we added up the rounds, the one values. So it would be a one if they advance to that round and a zero if not, added them up to create a rounds advanced category, and that's what we're plotting here in this bar graph. So obviously you can see 1 seeds advanced a very higher margin of rounds per per tournament run than any other. Um, which it does make sense as we'll talk about in a second. And then we kind of have this category from 2 to 4 that are around the same. Then we have the 5 seeds, 6, 7 seeds, 8, 9, the 10 seeds. And then we do see a little bit of a spike in the 11 seeds. And this is something that I think is interesting, which is that, not always being the higher seed is preferable. When you look at the 11 seeds, if we think about the teams that they're going to have to face, an 11 seed will face a 6 seed, and then they'll have to face a 3 seed. Whereas if you look at a 10 seed, they will face a 7 seed, and then they'll have to face a 2 seed. So if we think back to before about what we were talking about with, the ones and the twos really being ahead of the pack, yes, you might get an easier matchup as the 10 seed in the first round going against a 7 instead of a 6. But when you're the 11 seed and you face that 6 seed, if you can get past them, a 3 seed is really not as strong as a 2. So this is pretty interesting to me. I thought this was interesting. And when you're making your brackets and looking at which upset teams to pick, it's good to know that the 11 seeds are advancing advancing multiple rounds, advancing into that second weekend at a much higher rate than the 10 seeds are. So continuing off of this, I decided to create a linear regression model to model this data. So basically what we're doing here is we're predicting seed based off of a few of the factors that we found in the BartTorvik data set. So this is adjusted offense, adjusted defense, adjusted tempo is the adjusted underscore T. And then I also included the overall current strength of schedule, and the non-conference strength of schedule, just to see if those things would be different. So we can see here the coefficients that these had. So all of this pretty much makes sense to what you would think. As a team had a higher adjusted offensive efficiency, their seed was lower by 0.38 per adjusted offense increase of 1. Adjusted defense, pretty similar value, but in the opposite direction. So this does give some credible evidence towards the fact that you need an offense and a defense to succeed. But the defense does weigh a little heavier in this information, which I do think is important. That the teams that were defensively oriented, they might be at a little bit of a bonus here when it comes to their seeding and their performance throughout the season. And then lastly, tempo. The teams that played at a slightly higher pace, they seem to get a lower seed, although this value was not significant in terms of the p-value. So it's on the verge, but not quite. And then when we look at the strength of schedule, it's very interesting actually that a team with a lower strength of schedule will have a higher seed, which you might not always think that would be the case, right? You'd think, oh, teams are facing off against tough competition. They're probably going to be more likely to have more times to prove their value, prove their skill. But it seems like maybe those tough non-conference games just ended up weighing teams down to the point where, like it says here, if you you have a higher strength of schedule, your seed is not necessarily going to be helped out too much. So I do think that's something that's interesting. And then the next thing that I wanted to look at is the notable errors. So if we look on the left side, we can see some of the seed predictions with the notable errors here. And it's interesting that most of these teams are 10 or 11 seeds, and this does make sense. These are the bubble teams. These are the teams that the results could go either way. One thing that I do think is interesting is there's one big outlier of Wisconsin in 2022, where the model really only predicted them to be a 8 seed, but they did actually get seeded in as a 3. And taking a little bit more of a deep dive into what happened that season for Wisconsin, they went 25-8. They had a pretty successful year, but the efficiency metrics just really didn't like them. And I think one reason that that BartTorvik's data really didn't like them was the recency of their losses. So they did lose back-to-back games to end the season, including their loss in the conference championship tournament. So, like we were saying before, this data really does play into the recency and recent results. So I think the committee probably didn't put as much value into those recent results as the metrics did. And it's also possible that there was some kind of injury towards the end of the season or players being held out that caused this issue. So that's the linear regression model that I created. And there's more information within my code in terms of these notable errors and how the model actually performed. But it did predict about 96% of teams within two seeds, and it was about 68% of teams predicted within one seed. So I think that's a pretty successful model, and it is interesting that clearly the seeding is pretty closely correlated to the performance of teams in these efficiency-based metrics. Final thing that I did was I created a Shiny app so users can actually go on and use this data. So if we click on here, we can see the Shiny app over here. And basically what this allows you to do is filter by seeds, select a metric. So if we want to look at the offensive rating and we want to see how teams did, let's say we just want the recent few years. So we just want to look at 2021 through 2023. We can see specifically for those years in terms of offense. Very interestingly, see right here. So four seeds had a lower offensive rating than the five seeds. So if you want to go in here, you can see any amount of things based on the year you pick. And you can also just filter, certain seeds. Let's say I don't really care about the 12 through 16 seeds. I just want the 1 through 11 just to visualize that closer. You can do that too. So that is my final project. I think that it's very interesting, the results, just looking at the linear regression model. And clearly, the NCAA selection committee is putting a lot of value into these advanced metrics. And I think it's great to see the analytical revolution in college basketball continuing to go on. So thank you, and feel free to review my code or play around with the Shiny app yourself to get some more information.